Moving right on into section 5, so please make note of the change in your notebook. Section 5, exploring angle pairs. We're going to talk about a few different types of angles: adjacent, vertical, complementary, and supplementary. Supplementary angles can also be referred to as linear pairs, and we'll talk about the difference between. Adjacent literally means next to. So adjacent angles are going to share a side. So if we have angle A, B, C, and we cut that into two pieces with ray BD, we can see that angle ABD is adjacent to angle DBC. They share a common side of the angle. It doesn't necessarily mean they're complementary or supplementary. That depends on the extra information given. Vertical angles, we'll draw over here. If you're given two intersecting lines, line BC, line AE, vertical angles share a vertex and are directly across from each other. So angle ACD and angle BCE are vertical angles. And something important to note about vertical angles is that vertical angles are congruent. They have equal measures. So we can also tell that angle ACB is congruent to angle DCE because they are vertical angles. Complementary angles, a cool way to remember this is that you can turn this into a 9 and this shows you that it's 90 degrees. So complementary angles have to add up to 90 degrees. So using the example that we have up here, you can see that let's say you have adjacent angles. If there's that box in the corner telling you that it's a 90-degree angle, that means that you can add this angle plus this angle and set it equal to 90 degrees in order to find the measure of each angle. These are complementary angles that are adjacent, but you can have complementary angles that are not adjacent. So let's say the measure of this angle was 50, the measure of this angle is 40 degrees. They're complementary angles because they add up to 90, but they're not adjacent. Supplementary angles, again, cool way, turn it into an 8, you can think of as 180 degrees. They have to add up to 180 degrees. Again, they can be non-adjacent. So you can have an angle that, let's say, is 130 degrees and another angle that's 50 degrees. These are non-adjacent supplementary angles. They're not a linear pair. A linear pair is when you have a straight line, a straight angle, and we have a ray breaking it into two separate angles. The measure of this angle plus the measure of this angle has to equal 180 degrees because it's a straight angle. They'll tell you that AB is a line, which means that it has to be a straight angle. This angle and this angle form a linear pair because they form a line when you add them together, which equals 180 degrees. Now, especially when we start proofs, these are some things that you can assume. You can assume adjacent angles. You can see that they're sharing a common ray, a common side, so you can assume that they are adjacent. As long as it's telling you that it's a line, like if the proof that we eventually do tells you that there's a line AB, if this is the case, then you can assume that angles are adjacent and supplementary. If they're forming a straight line like we see up here, you can assume that this is 180 degrees. The last thing you can assume from what we've learned so far, as long as they tell you line AE and line BD, you can see that they're intersecting, so you can assume vertical angles. However, you can never assume, don't you dare assume, you make a out of you and me. You can never assume that angles or segments are congruent. Just because they look like they're the same size does not mean that they are the same size. You can also never assume right angles. This could possibly be just 81 or 89 degrees, but not exactly 90, and only exactly 90-degree angles are right. And also, you can never assume that two angles are complementary. So let's say that you're given a picture and a ray that breaks the angles apart. If the picture does not tell you that this is a right angle, then you cannot assume that these two angles add up to 90 degrees. So you can assume these three things as long as it tells you that it's a line or they're two intersecting lines, but you can never assume congruent angles or segments, right angles, or complementary angles. We talked when we were speaking of segments about segment bisectors. There's also angle bisectors. This is a ray that divides the angle into two congruent angles, which we can mark as two congruent angles, same amount of arcs. So let's say that we have angle ABC, and this is point D. We're saying that ray BD bisects angle ABC into two congruent parts. And those two parts would be angle ABD, which is congruent to angle DBC. Now, when you're naming angles, it is important that the vertex is the middle letter. The other two letters are interchangeable. You can switch them, but the vertex must be the middle letter. So let's try an example. Angle ABC is bisected by, make sure you have your notation, ray BD. If the measure of angle ABD is 3p minus 4, and the measure of angle DBC is 4p minus 6, what type of angles are they? So what type of angles are being formed when ray BD bisects the whole angle? So always draw a picture. It's easiest to see this way. The question tells us that the measure of angle ABD is 3p minus 4. It's bisecting it, so we know that they're congruent. And the measure of angle DBC is represented by 4p minus 16. Well, since it's telling us that the angle is being bisected, that means these are two congruent parts. If they're congruent, that means the measure of angle ABD is equal to the measure of angle DBC. So from here we can substitute. 3p minus 4 is the measure of angle ABD, so that must be equal to 4p minus 16. From here it's just simple solving equations. 3p plus 12 equals 4p. Subtract 3p from both sides, and we get that p equals 12. If p equals 12, you have to substitute that into each angle. So 3 times 12 minus 4. Well, 3 times 12 is 36. Minus 4 is going to give us 32 degrees. And 4 times 12 is 48. Minus 16 is again going to give us 32 degrees. So you can see that the two angles are congruent, which they should be. Both of those angles are less than 90 degrees, but greater than 0 degrees. So the angles that are being formed are acute angles. You would write your response in a complete sentence when it's asking you a question. The type of angles that are being formed are acute angles because their measures are greater than 0 degrees but less than 90 degrees.